So, Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Okay, so sorry start lambat sikit. Ada sedikit masalah teknikal. So, terpaksa start lambat sikit. Tapi lambat 5 minit lah. Okay, ikut Right, so now let us start with the last lecture for chapter 6. So that means this coming Wednesday, we are going to start with a new chapter, which is chapter 7. Oh, hi, morning. Okay, so can you guys listen to me clearly? Boleh dengar okey ke? Ada apa-apa masalah tak? Nampak macam lagging sikit lah internet. Okay je, alright. Tak apa. Okay, let us start then. Okay, so polynomial chapter 6. Let us do a bit of recap on what we had learned last week, and then we are going to continue with type 3 this week. Okay, so we have learned about 6.1, we have learned 6.2. So last week on Wednesday, we learned about the zeros of polynomial and then two types of partial fraction, right? So today we are going to focus more on the partial fraction. Okay, so the learning outcome for today, you should be able to decompose into a partial fraction when your denominator is a quadratic factor, ax squared plus bx plus c, that cannot be factorized. Okay, so now highlight this one. This one cannot be factorized. So this method, we only use them when the quadratic factor cannot be factorized. If they can be factorized, then it should either be a repeated linear or it might be the case for a distinct linear. So if you can factorize them, then those will be the linear case. So today we are going to look at a quadratic that cannot be factorized. Okay, and then once we are done with type 3 for the partial fraction, we are going to do something with the improper fraction, because so far we only learn how to decompose into partial fraction when we have a proper fraction. So now we are going to proceed to improper and then see what happens when we are trying to do partial fraction for the improper fraction. Okay, so B, change the rational polynomial to proper fraction when the degree of the numerator is the same or more than that of the denominator, and then determine the partial fraction. So that means we are going to look at improper fraction and then change it to partial fraction. Okay, so now a bit of recap on 6.3 partial fraction. Okay, so far what we have done is we have already looked at proper fraction, and then we have done the partial fraction for distinct linear as well as the repeated linear. And then I think I showed you last time that when we have a quadratic factor that can be factorized, then we should either have a repeated linear or a distinct linear. So that means if you can factorize them, then it will be the case for a linear factor then. So now today we are going to look at this one, a quadratic factor that cannot be factorized, and then the improper fraction. So this one as well as this one. Okay, so what happened when we have linear factor? Okay, so if you have denominator with distinct linear factor, if you have a distinct linear factor, you're going to write down some constant on top of them. So you are going to separate your denominator into two, because we have two over here. So separate them into two and then write down some constant on the top, and then we just need to find out what is the constant. Okay, so that is for the distinct linear factor. Okay, the second type, denominator with repeated linear factor. So in this case, we separate them into three because this is 2. So we have x plus 5 to the power of 1 and then x plus 5 square. So you separate them into three fractions. And then again, since this is linear factor, even though they are repeated, the linear factor, we still use some constant at top. So that is why you see some constant over here. And then same thing over here, this is repeated linear because we have x squared, so x to the power of 1, x to the power of 2, and then a linear factor 3x plus 5. Since all of them are simply linear, so that is the reason why we are using some constant. And then of course, the longer part is to simply calculate what is the value for A, B, and C. Okay, so now let us proceed with type 3. When we have a quadratic factor that cannot be factorized in our denominator, so always make sure when you have some kind of denominator, you need to make sure can you factorize them or not. So if let's say you didn't know how to factorize them by using this cross method or butterfly method or whatever you name it, if you didn't know how to factorize using this one and then you are actually using your calculator, then you should check, do you have any decimal? If you have any decimal, can you change it into fraction? Because you know, right, decimal, it can either be repeating, terminating, or it might never stop, right? So just check, can you change the decimal into fraction or not? If you can change it into fraction, then most likely they can be factorized. If you cannot change it into fraction, then that means you cannot factorize them because you will have some irrational number, of course. Another one to look out for is this sign. If you have I or perhaps something with I somewhere in your calculator, then it simply means that you cannot factorize them completely. So kalau kita nampak nombor yang macam ni, maksudnya kita boleh factorize tapi dapat imaginary kan. So we don't want imaginary number. So we just want a real number and they must be a rational number. So we cannot have irrational as well. Rational number. Rational. Kenapa macam stop je? Okay. Start balik dah muka. Alright, so now 7x plus 10 over x minus 2, x squared plus 7x plus 3. So x minus 2, this is just a linear function. That's the reason why you do have some constant at the top. And then x squared plus x plus 3, so those are actually a quadratic that cannot be factorized. So now we have to write them down in the form of bx plus c. Oh, by the way, this is cap c. I forgot to use caps lock for them. Okay, so bx plus c. So now our job is to actually calculate what is the value for a, b, and c. Okay, so similar thing over here, we have x plus 1 over x squared plus 1. So x is a linear function. So you have a quadratic on top, or a constant, sorry. So x is a linear, so you have a constant on top of them, which is a. And then x squared plus 1, you cannot factorize them further. So that's the reason why we are having some linear function at top, which is bx plus c. Again, it's supposed to be cap c. Okay, so now our job is to actually calculate what is the value for A, B, and C. Right, so let us go to example 1. Okay, example 1, we have two examples actually, one A and one B. So I'm going to do one A first, and then we are going to do one B. Okay, 1A, express 3 over x plus 2, x squared plus 1 in partial fraction. Okay, so look at your denominator. The most important thing in partial fraction is your denominator. Check them first. Okay, so I have x plus 2, so this is a linear function. So linear. And then x squared plus 1, this is a quadratic, but then you have to check your quadratic. Can you factorize them or not? Boleh factorize? Can be factorized. So answer is you cannot factorize them. Macam pelik dia pula. Bila buat macam tu sekejap. Bukan pelik apa sebab dia tak ada X kat depan kan. Okay, so this is a linear function. This is quadratic. Check, can you factorize them or cannot factorize? So obviously cannot factorize them. Okay, so now let us separate your denominator. So you will have 3 over x plus 2, x squared plus 1. So since we have a linear function over here, so you will have some constant, which is a. And then x squared plus 1, this is a quadratic that cannot be factorized. Therefore, we will have bx plus c. Okay, so for a quadratic that cannot be factorized, be extra careful. You might want to use a bracket for them. You might want to write down some bracket for them because it will be easier when we want to have a common denominator. So prepare some bracket for bx plus c, and then let's have the common denominator. Okay, so we will have a multiply with x squared plus 1 plus bx plus c multiply with x plus 2. over x plus 2 x squared plus 1. So this is the step where we have a common denominator. Okay, so once you have your common denominator, what you can do is that you can actually compare your numerator or equivalent of your numerator. Therefore, you will have 3 equal to ax squared plus 1 plus bx plus c x plus 2. So this is equivalent denominator. Okay, so now it comes for the solving part. So for the solving part, like what we have last time, we have two methods. So you can either choose to use substitution or you can use comparing coefficient, up to you. Whichever method that you find much more easier for you. So sometimes I do mix them as well. Kadang-kadang memang saya mixkan pun campur-campur sikit kadang-kadang. Right, so now if let's say I simply want to try to use substitution, so you might want to look at your denominator and then see what kind of zeros you have. Okay, so we have x plus 2, so that means the first one that I might try to use for my substitution is x equal to negative 2. Once I use x equal to negative 2, behind here x plus 2 will become 0, so that means I will be left with the value of a. But then x squared plus 1, I don't see any other zeros that can solve x squared plus 1 except of course imaginary number, but I don't want any imaginary. Okay, so now I don't see anything that can solve x squared plus 1. So that means I should choose any other number. Okay, what I can see over here is that I have bx. So that means my second number that I'm going to choose is perhaps x equal to 0. Because once I let x equal to 0, so that means b will be multiplied with 0. So I no longer have to consider what is the value of b. And then another one, you might want to choose any number that you want. Perhaps don't choose a very big number. You might get confused later on. So I already have 0, I have negative 2. So perhaps another one, x equal to 1. But if you don't want x equal to 1, perhaps negative 1. Or perhaps you want to choose 2 or perhaps 3. Just choose a small number. That will be quite okay. So once we have 3 value of x, we can actually substitute to find 3 unknown, which is a, b, and c. Okay, so let me try to substitute with x equal to negative 2. Okay, so I have 3 equal to a, negative 2 square. So negative 2 square is simply 4, 4 plus 1, so 5. A is actually equal to 3 over 5. So I already substitute with x equal to negative 2 over here. And then another one, I'm choosing x equal to 0. So let's see what happened when x equal to 0. Okay, so when x equal to 0, a will be multiplied with 1 because we have 0 plus 1, which is 1. And then b times with 0, that is simply 0. So I will be left only c for this bracket over here. So I only left with c, and then 0 plus 2 is simply 2. So I have 3 equal to a plus 2c. So I substitute the value of a. I already know the value of a. So c will be equal to 6 over 5. And then I choose any other number that I want to calculate the value of b. So I think I choose x equal to 1 because that is easier. Okay, so x equal to 1. So we have a times 2 plus b plus c times with 1 plus 2, which is 3. So over here we got 2a plus 3b plus 3c, and this is actually equal to 3. So in order to find out what is the value of b, you might want to do 3 minus 2a minus with 3c, and then you divide everything by 3. So that will be the value for b, which is negative 3 over 5. Okay, so that is for substitution. So you can actually choose any number that you want, and then you will get the value for A, B, and C. So I do find that the first number, it will be easier if you straight away go to the zeros of your denominator. So for example, over here, this is x plus 2. So I'm choosing x equal to negative 2 as my first value. So once I know that one, Then normally for me, my second part, if I have a linear, something like this, normally my second value will be x equal to 0. The third one, normally I'll just choose whatever that is left. Okay, so that is for substitution. So now the second method is by using comparing coefficients. So of course you need to expand them a little bit. Okay, so you will have 3 equal to a plus b x square plus 2b plus c x plus a plus with 2c. So make sure to expand them very, very carefully. Okay, and then of course you're gonna compare for x square x and then the constant. So if you compare for x square, you will have 0 equal to a plus b. If you compare for the x, it will be 0 equal to 2b plus c. If you compare for the constant, then 3 is equal to a plus 2c. So you will have 3 equations with 3 unknown. So up to you, however you want to solve them. And then solving them simultaneously, you should be able to get the value for A, which is 3 over 5, negative 3 over 5, 6 over 5. So we are supposed to get the same answer. So answer dia akan sama saja, cuma tengoklah macam mana or solve dia. Okay, biasanya kan macam mana kita nak solve 3 unknown, 3 equation with 3 unknown. Normally you have to get the fourth equation, fourth and fifth equation. Normally we will need another 2 equation with 2 unknown. Once you reduce them into 2 equation with 2 unknown, then you can easily solve them. Tapi ni untuk solve simultaneous equation lah. Tak apa lah. Nanti kalau ada masalah untuk solve simultaneous, bagi tahu. Yang ni nak tahu method je dulu. Macam mana method nak buat partial fraction. Okay, so now you already get the value for A, B and C. So go back to the first step and then simply substitute the value for A, B and C. Okay, so A is 3 over 5, B is negative 3 over 5, and then C is 6 over 5. So I simply substitute the value for A, B and C. So they will become 3 over 5, x plus 2, and then since I do see 5 for B and C, so I combine them together. So that is the reason why you have negative 3x plus 6 over 5, x squared plus 1. Okay, done with 1A. So now 1B. So 1B, express 4x plus 1 over x plus 1, x squared plus 5x plus 1 in partial fractions. Again, do check your denominator. So x plus 1 is simply a linear function. X squared plus 5x plus 1, those are quadratic. So check first, can you factorize them or not? Actually, this is quite obvious, right? We are in type 3, so obviously they cannot be factorized. But of course, in their situation, you might want to check first, can you factorize them or not? Okay, so x squared plus 5x plus 1, those are quadratic that cannot be factorized. So we know for sure when we separate our denominator, we are supposed to get some linear function at the top. Okay, so now I'm going to separate my denominator. So I have a over x plus 1 plus bx plus c over x squared plus 5x plus 1. Again, you might want to write this inside some bracket first, and then make sure you have a common denominator. Okay, so a will be times with x squared plus 5x plus 1. Bx plus c will be times with x plus 1. So we are going to have a common denominator next. And then you are going to make the equal sign for your numerator, or we are going to compare our numerator because we have the same denominator over there. So you're going to compare at the top. So you have 4x plus 1 equal to a x squared plus 5x plus 1 plus bx plus c x plus 1. So this is equivalent in the numerator part. Okay, so now we are coming to the solving part where you have to calculate what is the value for A, B, and C. So we have two methods. You can either use substitution or you can use comparing coefficient. So I'll give you around 3 minutes. is find out what is the value for A, B and C. 3 minit cukup lah. Okay, so 3 minutes, okay? Until 8:29. So find out what is the value for A, B and C. So just find out. You might want to use substitution, comparing coefficient, and then just find out what is the value of A, B and C. Cari je lah, tengok dapat tak. Sementara tu saya boleh check kehadiran dulu. Ada orang isi kehadiran awal sangat lah. Oh, by the way, you do realize that next week is our mid-sem break, right? Oh, can't wait. Tak sabar ni. Tak sabar nak cuti. Ho 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 ho. Sikit lagi. Okay, so it's already 8:29. How was it? You get the value for A, B and C. Okay, so siapa yang dah dapat boleh tulis. Dah tulis nanti baru kita proceed. Miss yang jalan kira kedua tu kenapa X tambah 2 sebelah kanan? Sekejap. X tambah 2 kat mana sebelum ni ke? Tengok. X tambah 2 kat sebelah kanan. Yang ni ke? Macam ni. Satu B. Okay, side. Oh, yang ni. Yang ni lah. Sekejap yang ni. Patut satu. Sebab saya copy. Saya copy daripada the previous one. So saya terlupa nak tukar. Sorry. So nanti tukar Tak perasan nak. Nasib baik awak sebut. Nak tukar siap-siap ke? Boleh lah. Tukar siap-siap nanti save senang sikit. Sekejap. Lari dah. Sekejap. Ni. Okay, betul lah. Baik, dah. Dapat dah. Okay, so apa cerita? Nilai A, B dengan C tu. What's the value of A, B and C? What's the value that you are trying to substitute? Come on, what's the value of A, B and C? A equal to jeng, 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 jeng. A1, B negative 1, C equal to 2. Okay, one answer. Next. We have one answer from Asfar Syazwani. Next. Sama nama. Depan je tak sama. Next. Sama je ke? Semua jawapan sama. I need one more. One more answer. Vamos. Okay lah, rasa macam tak bangun lagi pagi ni. Kasih Chan lah. Rasa macam tak bangun lagi tu. Okay, tak apalah. Right, so now, what is the value that you are going to try to substitute? This is substitution, right? So normally for me, my first value that I'm going to try to substitute is x equal to -1. Why? Because if I choose x equal to -1, then at the back, everything will be multiplied with 0, so I don't really need to calculate them. So if I use x equal to -1, I will get the value for A straight away. And then the second one, like I told you before, normally I will use x equal to 0 because I have bx over here. So normally my second value will be x equal to 0. And then the third one, I already have 0, I have -1, so I might want to use x equal to 1 because I do find the smaller number the easier for me. Okay, so now we are going to try to substitute with x equal to -1. So when you substitute with x equal to -1, you are going to get the value of A, which is equal to 1. Substitute with x equal to 0. Then you are supposed to see that C is actually equal to 0. So be extra careful, okay? Right. And then B. So substitute x with 1, we are going to get 4 times 1 plus 1 equal to 7a plus 2b plus 2c. So simply substitute c equal to 0, a equal to 1, then you will get that the value for b is actually -1. Okay, so almost there. Very good. Next. Other than substitution, of course, you can also expand them to use comparing coefficients. So I'll just show you how to expand. Okay, so when you expand them, it might look a little bit tedious, but never mind, just proceed. Okay, so comparing for x square, you are going to compare. So 0 is equal to a plus b. Compare for x to the power of 1, you are going to get 4 equal to 5a plus b plus with c. And then when you compare for x equal to 0, x to the power of 0, sorry, constant. So 1 is equal to a plus with c. Okay, so once we are done, either substitution or comparing coefficient, just substitute them back into the value for A, B and C. Kenapa 1 tolak 5 tambah 1, 1 tolak 5 tambah 1? Over here, I substitute with x equal to -1. So when I substitute with x equal to -1, you substitute into x square over here, they will become 1. If you sub x with -1, because we have -1 square, which is 1. And then you have 5 multiply with -1. So they will become -5. And then 1 will stay as 1. So that is the reason why you have 1 minus 5 plus 1. Okay, Fat? Fat ke Sophie? Tak tahu lah. Aku panggil Fat, aku panggil Sophie. Aku sukalah. Okay, so 1 minus 5 plus 1. Okay, next. Once you have the value for A, B and C, oh, by the way, this one we haven't solved them yet. So solve them, you will get the same value for A, B and C. So ini kena solve. And then substitute into the fraction. So substitute the value in. So that will be your final answer, which is 4x plus 1 over x plus 1. X squared plus 5x plus 1 equal to 1 over x plus 1 minus x. Okay, so do check over here. This is bx plus c, okay? So when you substitute the value of b, you should remember that you have to multiply them with x. So this is -x plus c. Okay, so yang ni biasanya yang tersalah sikit lah. Tersalah sebab dia tinggal x tu, sebab dia bx So jangan lupalah dia ada x kat atas ni. Okay, so those are for proper fraction. So we have done type 1, type 2 and type 3 for the proper fraction. So now we are going to proceed to improper fraction. Okay, so case 2, improper fraction. So when we have an improper fraction, so either the power for the numerator is equal to our denominator. So for example, x square over x square, I just give you a simple one, x square over x square. And then if we have improper, they will be x cubed over x square. Sekejap, apa ni? Kenapa C dalam equation substitute 2 darab dengan 1 bukan bx tambah C ke? Okay, sekejap. Patah balik. Kita patah balik sebab ada soalan. So kita patah balik. Okay, apa dia kata tadi? Kenapa C dalam equation substitute? Okay, C dalam equation substitute bukan bx tambah C ke? Substitute 2 darab dengan 1. Substitute 2 darab dengan 1. Substitute 2 darab dengan 1. Confused sekejap. Okay, sekejap. Macam mana cakap? Kenapa C dalam equation substitute 2 darab dengan 1? Dekat sini kita kata x equal to 1 kan? Lari dah mouse ni. Okay, so x is equal to 1. Okay, so when you try to substitute x with 1, you are going to get A. Okay, tak apalah. Yang ni akan jadi 1 plus 5 plus 1, right? And then plus, okay, so we have bx plus c. So b times 1. So those will become b plus c. Oops. And then 1 plus 1, which is 2. Hopefully I do answer your question. Boleh? Hakim? Tak apa, nanti bagi tahu balik. Kalau kata tak clear lagi, nanti bagi tahu yang mana satu. Okay, next. Let me go back to the improper part. Okay, so what did I mention about improper? Okay, so you have two kind of fraction in order to have improper. So you might have the same power for the numerator and denominator atas equation yang ni. Oh, atas tu. Okay, Sat, patah balik lah. Okay, Sat. Hmm, hmm, yang ini. Yang ini x equal to 0. So bila x equal to 0, sebelah kiri okey lah kan. 4 times 0 plus 1, okey. So 4 kali kosong tambah 1, ini 1 lah kan. Sama dengan, okey, so A, yang ni kita akan dapat kosong, kosong, 1. So A kali 1. Okey, lepas tu B darab dengan kosong. So dia akan jadi kosong. Tambah C. So tinggal C sajalah kat dalam bracket tu. Tinggal C saja. Kemudian kosong tambah 1 akan dapat 1. So maksudnya kita akan dapat 1 tu sama dengan A tambah C. So A adalah 1 tambah C. So 1 sama dengan 1 tambah C. So C dia kena sama dengan kosong lah. Atas yang ni kan awak kata. Okay, tak apa. Next. Oh, saya memang skip sikit step tu sebab nak tekankan konsep partial fraction lagi daripada solving tu. Okay, so now again proceed to improper fraction. Okay, so now what is the highest power for this one is x cubed. The highest power for our denominator is x squared. So I know for sure this is actually the case for the improper fraction. So if you have an improper fraction, what do you need to do is a long division. So once you do your long division, so it will be px over dx, right? So when you do the long division, you will have qx plus rx over dx. Okay, so we are going to do the partial fraction with this one. So you're going to consider this and then separate them into the partial fraction, and then later on copy down the question again together with the qx and then together with the answer for your partial fraction over here. So kita akan fokus kepada fraction tu, macam mana nak pecahkan dia. Lepas tu masa last jangan lupa tarik balik lah. Okay, so I'll show you one of them. Okay, so in example 2, we have to express 3x squared plus 5x minus 2 over x plus 3 in partial fraction. Okay, so first thing first, we have to check what kind of fraction do we have. Okay, so I'm sure you know by now it is supposed to be improper, right? Because we are in the case for improper fraction. But let's say, just imagine, okay, just pretend you didn't know. Okay, so this is x squared. The highest power for our numerator is x squared. The highest power for my denominator, try to expand them a little bit. So we got x squared. So we do have x squared over x squared. So x squared over x squared, that means we have the same power for numerator and denominator. This is the case for improper. Okay, so since this is improper fraction, I have to do a long division first. Okay, so you might want to expand your denominator a little bit so that it will be easier for us to do the long division. So x multiplied with x is x squared plus with 3x. Okay, so we are going to do the long division for them. Okay, so 3x squared plus 5x minus 2 divide with x squared plus with 3x. So ini bukan simbol ni, dia sepatutnya kena macam ni. Okay, tak apalah. Right, so now x squared multiply with what in order to get 3x squared? So obviously x squared will be multiplied with 3. So multiply them with 3. We are going to get 3x squared plus with 9x. So x squared multiply with 3, we are going to get 3x squared, 3x multiplied with 3, they will give us 9x. And then of course we should deduct them. So minus, so 3x squared minus 3x squared, they will become 0. And then 5x minus with 9x, they will become negative 4x. So we will have negative 4x negative 2. Do check, can you still proceed or not? Okay, so now this is my remainder, which is 4x. The highest power is x to the power of 1. The divisor is x squared. So the power for my remainder is lesser compared to my divisor. So I will stop over here. So bila remainder tu dah kurang daripada divisor, stop. Okay, stop. And then we are going to write them down in the form of px over dx equal to qx plus rx over dx. So that is what we learned in lecture 1. Okay, so write down px over dx. And then we have qx plus rx over dx. Okay, so since I have negative 4x, negative 2, so I choose to factorize the negative out. You can choose not to factorize them. That is totally up to you. So for me, I prefer to factorize the negative out. If you don't want to, that is also okay. Up to you. Okay, so now let me consider 4x plus 2 over x plus 3. So I will do the partial fraction for this one. So we are going to consider, or we are going to look at 4x plus 2 and then check what kind of denominator do we have and then separate the denominator, proceed, etc. etc. Okay, so now focus on 4x plus 2 over x minus x plus 3. Okay, so now 4x plus 2 over x plus 3. So I have a distinct linear. So that's the reason why we are having a over x plus b over x plus 3. So this is the first step when you separate your denominator. So step 1. Okay, so yang ini saya dah tak tulis lah yang kotak-kotak tepi tu sebab dah daripada lecture 2 lagi kan, dah nampak kan. So sekarang kita masuk je working. Okay, so this is when you separate your denominator. Next, you need to have a common denominator. So you will have 4x plus 2 over x plus 3, a multiplied with x plus 3 plus with bx. So this is the second step where you have a common denominator. Okay, so once you have a common denominator, then you can equivalent your numerator. So you will have 4x plus 2 equal to a 3x. Ax plus 3 plus bx. So this is step 3. And then for step 4, choose either one or you can choose to use both. Up to you. So normally for me, I'll use one of them. Tapi kadang-kadang saya suka juga campur-campur pun. Okay, so now you can solve either by using substitution or comparing coefficient. Up to you. As long as you get the value for a and b. Okay, so I'm using some substitution over here. When x is equal to 0, then a is equal to 2 over 3. And then when x is equal to negative 3, b is equal to 10 over 3. So I'm using some substitution over here and then I get the value for a and b. So this is the fourth step where we are going to solve to find out the value for a and b. Okay, so you can also use comparing coefficient, up to you. Now what happened is that we are going to copy down the first step over here and then substitute the value of a and b in. Okay, so substitute the value for a and b in. Okay, so we got 3 minus 2 over 3x plus 10 over 3x plus 3. So those are your final answer. Tapi jangan lupa yang ni adalah untuk yang belakang tau. Jangan lupa tarik balik awak punya QX quotient, your quotient over there. Don't forget to copy them again. Okay. Done with the first one. Okay, done. So now let us proceed with the second one. I think this is the last example on chapter 6. Okay, so express x square minus x minus 5 over x plus 2 x square plus 1 in partial fraction again, of course. Okay, so again, do check what kind of fraction do we have. If we have proper straight away, if we have improper long division first. Okay, so the highest power for my numerator is x cubed. So that is the highest power for my numerator. For my denominator, the one at the bottom, so the highest power is x multiplied with x squared, which will give me also x cubed. So I have the same power for my numerator and my denominator. Therefore, I know for sure this is the case for improper fraction. Memanglah kita tahu ni case 2 tapi pretend lah. Anggaplah macam tak tahu kan. So test dulu. Okay, so now improper fraction, therefore you have to do the long division. So you might want to expand your denominator carefully because we have to divide them. Okay, so now x cubed minus x minus 5. And then we are going to divide with x cubed plus 2x squared plus x plus 2. So that is what happened when you expand your denominator. Okay, so x squared multiply with what in order to get x squared? So of course we have to times them with 1. Oh, by the way, always make sure that your either your numerator or your denominator, they must be in descending order. Maksudnya jangan miss apa-apa term Kalau miss apa-apa term tu nanti biasanya dia akan ada masalah sikit bila kita bahagi. Okay, so now I will times them with 1. So copy down again. So we got x squared plus 2x squared plus x plus 2 minus them. So they will become negative 2x squared, negative 2x, negative 7. Okay, so I will write them down in the form of bx over dx. So I will have 1 minus 2x squared plus 2x plus 7 over x plus 2 x squared plus 1. Okay, so now we are going to focus on this proper fraction. And then we are going to do partial fraction for this one. And then once I separate them into partial fraction, I get the value of them. Then we can go back here and then substitute the fraction. Okay, so let us focus on 2x squared plus 2x plus 7 over x plus 2x squared plus 1. And then just check what kind of denominator do we have. Okay, so x plus 2, those are linear. But for x squared plus 1, those are quadratic. So if you have a quadratic function, you should check first, can you factorize them or can't you factorize them? So obviously x squared plus 1 cannot be factorized. So those are the case where we just learned just now, where it is a quadratic that cannot be factorized. So let us see when we separate them what happened. Okay, so now separating them, x plus 2 is simply a linear. So we are going to write down some constant at the top, which is a over x plus 2. X squared plus 1 is a quadratic that cannot be factorized. So I'll be sure to write down some linear function. So those will be bx plus c. Okay, so now our job is to actually find out the value for a, b, and c. Don't forget bx plus c need to be inside a bracket. Okay, so what happened? Make sure you have a common denominator and then compare your numerator. So you will have 2x squared plus 2x plus 7 equal to a, x squared plus 1 plus bx plus c multiplied with x plus 2. And then you can choose either to use substitution or comparing coefficient. Choose either one. So you can choose comparing coefficient or you can choose substitution, up to you. So normally for me, I'll choose substitution first because I want to let this term become 0. So I'll choose x equal to negative 1. Is this one? Negative 2. X equal to negative 2. So substitute on left, substitute on the right hand side. So this term will become 0. So we have 0 over here. So I will find out the value for a then. So a will become 11 over 5. And then substitute another value for B and C. So perhaps substitute x equal to 0. And then another one maybe x equal to 1 or x equal to -1. Then we can easily find out what is the value for B. Okay, so now substitute the value when x equal to 0. That will give us the value for C. Okay, so I'll give you straight away. C is equal to 12/5. And then use another value to get the value for B. So maybe x equal to 1. Just choose a smaller number so that you can easily calculate them. Sebab kadang-kadang bila pilih nombor 1 juta tu saat kita tinggal kosong ke apa ke payah. Boleh nak pilih tak salah. Boleh. Nak pilih nombor yang macam rare sikit kan. 667788 pun boleh juga. Nak nombor yang rare pun boleh. Tapi nanti awak lah nak kira payah sikit. Ikutlah. Kalau untuk saya kata pilih nombor yang kecil lah. Mudah sikit. Okay, next. Right. So now the value for B is -1/5. And then once you have the value for A, B and C, go back, try to substitute the value for A, B and C. So your final answer will be 1 minus 11/5 x plus 2 plus 12 minus x over 5 x squared plus with 1. So do be extra careful over here. Okay, so I think that's it for polynomial. I think I don't have any more example after this. Ada lagi ke? Tak ada lah. Okay, done. Right, so saya rasa step yang kira tu kena kira sendirilah. Kira, masukkan nilai sendiri, pastikan dapat jawapan. Kalau tak dapat, kena inform balik lah. Kalau kata ada apa-apa masalah kan. Okay, so I think that's all for chapter 6. So I'll see you guys later. So jumpa sekejap lagi lah. Kita masuk tutorial. Okay, so jumpa sekejap lagi. Tunggu saya bagi link lah untuk Google Meet. Tapi nanti ingatkan saya kena rakam Google Meet tu. Okay, bye-bye. See you. Siapa yang belum isi attendance, sila isi Jangan lupa attendance.